Today, this video is to remind you of the law of sines and maybe for some of you, introduce you to the law of sines. So before we do some examples, we're just going to review what the law of sines allows us to do. And basically, it's a way for us to solve pieces of a missing pieces of a triangle that is not a right triangle. Okay? And call it triangle ABC. We're going to call this angle alpha and this angle beta, which means that side B is across from angle B and side A is across from angle A, side C across from side C. Now, if we wanted to, we would be able to divide this in half and actually make it two right triangles, okay, where this would be H. However, the law of sines, what it allows us to do is to take the sine of any angle, so we'll start with sine of alpha, over the side length across from it, so over little a, and that should then be equal to the sine of a different angle, so we'll say sine of beta over that side length. So it's always talking about an angle and a side across from it compared to a different angle and a side across from it. I call this a y up there. So we could also do sine of that angle over side C. Now, obviously, we would never use three pieces at the same time. So at any given time, you're using two of these ratios. Now, because of the way fractions work, we could also flip them all. So we could do the side length divided by sine of alpha equal to side length B over sine of beta, or equal to side length C sine of y. Okay, so again, at any given time, you're only using two of those fractions, but if we know 3 out of 4 pieces, we will be able to solve for the fourth using the law of sines. So an example would look like this. If beta is 85 degrees, y is 40 degrees, and b is 26. Solve for a triangle ABC. So I start by drawing a picture, and again, labeling my triangle. In this case, I said triangle ABC. Again, it doesn't matter which one you called A, which one you called B, and which one you called C. Wherever angle B is, call that 5. Or 85 degrees, sorry. The angle at C is the 40 degrees. We don't know A, so we're not doing anything with that, but then they also tell me that B, so the side across from angle B, is 26. Now, reminder that when it says solve a triangle, that means find all the missing sides and lengths. So all the missing pieces. All right. So the first thing I'm going to do is use the law of sines, and since I know angle C, I can find side C from that. Okay? I could also solve for angle A first, but I'm going to start by solving this one. So because I am solving for a missing side length, I'm going to use these over here. So this is when I want to use find missing length. And I use it in this form when I find missing angle. It doesn't really matter. Okay. So I'm going to do little c over sine of 40 equals 26 over sine of 85. And we did review that if we have two fractions equal to each other, we can technically cross multiply, but the reason I wanted c on top because it's going to be quicker for me to just do times sine of 40. If I multiply both sides by sine of 40 degrees, I get c equal. And so I would just do 26 times sine of 40, because really that's all on top. So 26 times sine of 40 divided by sine of 85, and I got 16.8 degrees. So make sure you're, oh, not degrees, sorry, we're finding a length. 16.8. So this side is 16.8. Again, to find angle A, I can quickly do 180 minus 85 minus 40, and that gives me 55 degrees. And now to find side A, I would do A over sine of 55 degrees equals, and I'm just going to stick with using B, the original one I had, 26 over sine of 85. Again, in this case, I'm going to multiply both sides to sine 55. I'll show it a little bit better here when I do that. I would get A equals, and I would do 26 times sine 55 on my calculator, and then divide by sine 85. I get 21. So you can see by using the law of sines and the sum of the angles in a triangle, I was able to find all 6. I encourage you to pause the next one and then try it on your own, and then play the video to make sure you did it correctly. Okay, so for example 2, once again, I draw my triangle, and I called it angle ABC. Again, you could have had yours in different orders. So angle A is always my alpha, B is always my beta. So in this case, angle B is 36 degrees. Side, or angle A is 72 degrees, and side A is 15. That's what. So the first thing I could solve for would be side length B. So I'm going to do B over sine of 36 equals, and then I know the side length of A and the angle of alpha. So this is how I should have set it up. B over 36 equals 15 over sine 72. Okay. Type it into my calculator, and I got B is 9.3. Put that on my triangle. That's over here. Then I'm able to solve for angle C, which is 180 minus 72 minus 36. So angle C would be 72 degrees as well. And actually at that point, because this is an equilateral triangle, I can actually just know that this side is 15, because if these angles are the same, the sides opposite them have to be the same. But again, if you didn't recognize that, you could have just done C over sine of 72 equals 15 over sine of 72. Again, there you probably would just recognize that C has to be 15, because when I multiply by sine of 72, they cancel, multiply by sine of 72, they cancel. Okay, so one step easier because it happened to be an equilateral triangle, but that was a unique situation. So that is your introduction into the law of sines. Now, from that introduction, you should be able to get a start on assignment number 1. Go to page 484. Those will be practices of those. I'll make a different video for all the ambiguous case, which makes the law of sines a little bit more complex. Thank you.